Welcome to Beyond Matrix. Today's episode we will be finding the true formation of stars. This episode will show how star took shape, how science and Vedic science explains. Before there was life, there was light. Before light, there was fire, waiting to awaken. After the universe cooled enough to become transparent, a fact confirmed by the cosmic microwave background, after matter separated from radiation nearly 380,000 years after the Big Bang, something extraordinary occurred. Gravity began to dominate, in the silence of expanding space. Birth of stars, cosmic fire. Modern science confirms with remarkable clarity that stars are born not in isolation, but deep within vast molecular clouds, cold, dense regions of space mapped in detail by radio and infrared telescopes. These clouds are composed primarily of hydrogen and helium, in proportions that match precisely the elemental ratios predicted by Big Bang nucleosynthesis, linking star formation directly to the universe's earliest moments. Within these clouds, slight density fluctuations, often triggered by shock waves from nearby supernovae or galactic interactions, begin a slow but irreversible process. Gravity pulls matter inward, causing regions to collapse under their own weight. As the cloud contracts, gravitational potential energy converts into heat, pressure increases, temperature rises, and the collapsing core grows ever denser. When the core temperature reaches approximately 10 million kelvins, a critical threshold is crossed. At this point, hydrogen nuclei possess enough kinetic energy to overcome their natural electrostatic repulsion. Nuclear fusion ignites. Protons combine to form helium through a chain of reactions that release enormous amounts of energy. This process is not hypothetical, it is verified mathematically through nuclear physics, experimentally through controlled fusion research, and observationally through stellar spectra and neutrino emissions detected from the Sun and other stars. Fusion marks the moment a star is truly born. The outward pressure generated by fusion balances the inward pull of gravity, stabilizing the star and allowing it to shine for millions or billions of years. At the heart of this transformation lies one of the most profound insights in all of physics, Einstein's mass-energy equivalence. Expressed by the equation E equals mc squared, it reveals that matter and energy are not separate entities but interchangeable forms of the same underlying reality. In stellar fusion, a small fraction of mass is converted directly into energy, released as light and heat. This is not theoretical abstraction, it is measured reality. The Sun loses millions of tons of mass every second, converted into energy that sustains life on Earth. The same principle operates in nuclear fission reactors and in high-energy particle accelerators, where matter is created from energy and energy released from matter. These experiments confirm what Einstein predicted: matter is condensed energy, and energy can transform into matter. When light escapes from a newly ignited star, it marks more than illumination, it marks transformation. No destruction has occurred, nothing has been lost. Instead, potential has become expression, compression has become radiance. The universe has discovered another way to speak. Stars are not explosions frozen in time, they are ongoing processes, sustained by the continuous conversion of mass into energy. In this sense, cosmic fire is not violent, it is creative. Each star stands as living proof that the universe evolves not by breaking its own laws, but by expressing them fully. The Ved, Agni Tattva, transformation is the first principle. In Vedic science, the force that ignites stars and drives cosmic change is understood through Agni Tattva, a principle far deeper than physical fire. Agni is not merely flame, heat, or combustion, it is the cosmic agent of transformation, the process by which the unmanifest becomes manifest and potential becomes expression. The very first hymn of the Rig Veda, 1.1, opens with the invocation of Agni, not as a ritual symbol, but as the primordial force of emergence. Agni is described as the messenger between realms, the bridge that carries essence into form. This placement is deliberate and philosophically precise. Before structure, before matter, before form, there must be transformation. Agni precedes all creation because without transformation, nothing can appear. Science arrives at the same truth through a different path. Modern physics does not begin with solid matter as the foundation of reality, it begins with energy. Einstein's mass-energy equivalence, expressed through E equals mc squared, demonstrates conclusively that matter is not fundamental, it is a condensed state of energy. In stars, this principle is visible and measurable. Nuclear fusion converts mass into energy, releasing light, heat, and radiation. Matter does not exist independently, it is continuously transformed. The star shines not because matter exists, but because matter is being transformed. Science explains the mechanism, how hydrogen nuclei fuse, how mass converts into energy, how pressure and temperature sustain equilibrium. Vedic wisdom explains the role, why transformation itself is primary, why change is not secondary but foundational. The connection between the Rig Veda and Einstein is not metaphorical, it is structural. The Rig Veda asserts that Agni precedes form, that transformation is the first act of existence. Einstein proves that energy precedes matter, that form arises from transformation. Both traditions, separated by millennia and method, converge on the same insight: reality is not built from static substance, but from dynamic process. Where the Rig Veda expresses this truth philosophically, through hymn, symbol, and insight, Einstein expresses it mathematically, through equations verified by experiment. Different languages, different tools, but the same underlying reality revealed. Fire, in this deepest sense, is not destruction, it is the universe learning how to exist. Galaxies, cosmic architecture, stars do not form in isolation, they assemble. Modern astronomy reveals that galaxies form along dark matter filaments, structures inferred from gravitational lensing in cosmic simulations. Though invisible, dark matter shapes nearly 85% of cosmic mass. Gravity organizes billions of stars into spirals, ellipses, and clusters, patterns confirmed by deep field observations from the Hubble and James Webb telescopes. Chaos yields structure. This is not coincidence. Galaxies represent one of the most profound demonstrations that the universe is not a random scatter of matter but a deeply structured system governed by invisible laws and forces operating across unimaginable scales. Stars, contrary to early intuition, do not form as isolated entities drifting independently through space. They emerge and evolve within vast, interconnected cosmic environments shaped long before the first star ignited. Modern cosmology shows that galaxies assemble along an immense framework known as the cosmic web, a network of filaments, nodes, and voids composed primarily of dark matter, a form of matter that does not emit, absorb, or reflect light, yet reveals its presence through gravity. Observational evidence from gravitational lensing, where the light of distant galaxies is bent and distorted by massive unseen structures, confirms that dark matter outweighs ordinary, visible matter by roughly 5 to 1, accounting for nearly 85% of the total matter content of the universe. These dark matter filaments act as gravitational highways, guiding the flow of gas and dust across hundreds of millions of light-years. As baryonic matter, hydrogen, helium, and trace elements falls into the deep gravitational wells created by dark matter, it cools, condenses, and fragments, ultimately forming stars and stellar systems. Over cosmic time, these star-forming regions grow, merge, and organize into galaxies, whose shapes are not arbitrary but reflect their formation histories and environments. Spiral galaxies arise when angular momentum causes infilling matter to flatten into rotating disks, producing graceful arms traced by young, luminous stars and interstellar gas. Elliptical galaxies, often found in dense clusters, are the aftermath of repeated mergers that randomize stellar orbits and exhaust star-forming material, leading to smooth, spheroidal structures dominated by older stars. Irregular galaxies bear the scars of gravitational interactions, tidal forces, and incomplete formation. These patterns are not speculative, they are directly confirmed by deep field observations from the Hubble Space Telescope and, more recently, the James Webb Space Telescope, which allow astronomers to peer billions of years into the past and observe galaxies in various stages of assembly, revealing that structure emerged remarkably early in cosmic history. Large-scale surveys such as the Slowing Digital Sky Survey map millions of galaxies and show unmistakable filamentary distributions that match predictions from computer simulations based on cold dark matter models and general relativity. What initially appears as chaos, a universe born from extreme density and temperature fluctuations, inevitably yields structure because gravity amplifies tiny irregularities in matter distribution, causing dense regions to grow denser while emptier regions become vast cosmic voids. This process is mathematically predictable and observationally verified, demonstrating that galaxies are not cosmic accidents but natural outcomes of fundamental physical laws operating consistently across time and space. The universe does not randomly scatter matter, it organizes it, following principles embedded in its very fabric. Thus, galactic architecture stands as compelling evidence that order can arise from primordial simplicity, not through coincidence, but through the quiet, relentless action of gravity shaping the universe into the vast, luminous structures we observe today. In Vedic cosmology, this order is called RTA, the cosmic law that governs harmony and balance. RTA is not enforced, it emerges naturally. Vishnu represents this sustaining principle: preservation without interference. Galaxies rotate with measurable precision, orbital systems stabilize, cosmic equilibrium appears inevitable, not because it is commanded but because balance is fundamental. In Vedic cosmology, the emergence of large-scale order in the universe is understood through the principle of RTA, a foundational concept far older than later philosophical or religious codifications. RTA is not a law imposed from outside creation, nor a command issued by a deity. It is the intrinsic rhythm and coherence of existence itself, the pattern by which reality naturally organizes and sustains harmony. The earliest Vedic hymns, particularly in the Rig Veda, describe RTA as the underlying order that governs the motion of the sun and stars, the alternation of day and night, the seasons, and the predictable behavior of natural forces. In this worldview, the cosmos is not chaotic matter waiting to be disciplined, but a self-regulating system whose balance arises from its own internal logic. This idea aligns strikingly with modern cosmology's discovery that galaxies rotate with extraordinary precision, that orbital systems stabilize through gravitational feedback, and that large-scale cosmic structures persist over billions of years without external correction. In Vedic thought, Vishnu embodies this sustaining principle, not as a micromanager of events, but as the state of preservation itself. Vishnu's role is often misunderstood as interventionist, but the deeper metaphysical meaning is subtler. Preservation occurs because the system is already aligned with RTA, not because it is constantly being adjusted. This is why Vishnu is depicted as resting on the cosmic ocean, in yogic stillness, symbolizing stability through equilibrium rather than control, galaxies rotating in stable configurations, planetary systems maintaining long-term orbital resonance, and cosmic structures persisting across immense spans of time mirror this principle precisely. The universe does not require continual enforcement to remain ordered. Feedback mechanisms inherent in gravity, angular momentum, and energy distribution naturally lead to equilibrium states. Vedic seers perceived this not through telescopes, but through deep observation of nature's consistency and introspection into consciousness itself, concluding that balance is not a temporary condition but a fundamental property of reality. Thus, when Vedic cosmology speaks of RTA, it is describing a universe where order is emergent, inevitable, and self-sustaining, not because it is commanded by an external authority, but because harmony is woven into the structure of existence. In this light, cosmic equilibrium is not an achievement but a default state, and preservation is not resistance to change but the continuity of balance through transformation. This perspective does not oppose scientific understanding. It anticipates it in philosophical language, recognizing that the universe evolves not toward disorder alone, but towards structured complexity guided by principles that require no enforcement, only existence. Death of stars and birth of elements. Stars, despite their immense size and power, are not eternal. Their lives are governed by a delicate balance between two opposing forces, outward pressure from nuclear fusion and inward pull of gravity. For most of a star's life, this balance remains stable as hydrogen nuclei fuse into helium in the stellar core, releasing energy that counteracts gravitational collapse. However, in massive stars, this equilibrium is temporary. As hydrogen fuel becomes depleted, the core contracts and heats up, igniting successive fusion stages in which helium fuses into carbon, carbon into oxygen, oxygen into neon, and so on, forming progressively heavier elements. Each stage releases less energy than the last, and eventually, the process reaches iron, a crucial boundary in nuclear physics. Iron fusion does not release energy, it consumes it. When an iron core forms, the star can no longer generate the pressure needed to resist gravity. In a fraction of a second, the core collapses under its own weight, reaching densities comparable to atomic nuclei. This catastrophic collapse rebounds violently, producing a supernova explosion, one of the most energetic events in the observable universe, briefly outshining entire galaxies. These explosions are not theoretical constructs, they are directly observed through optical telescopes, X-ray observatories, and neutrino detectors, such as the detection of neutrinos from supernova 1987A, which confirmed core collapse models predicted decades earlier. The scientific significance of supernovae extends far beyond stellar death. They are the primary factories and distributors of heavy elements in the cosmos. While hydrogen and most helium were formed during the early universe's nucleosynthesis, nearly all elements heavier than helium, collectively known as metals in astrophysics, are created inside stars through nuclear fusion and neutron capture processes. In the intense conditions of a supernova, rapid neutron capture, the R process, forges elements heavier than iron, including gold, uranium, and platinum. Stellar spectroscopy provides direct evidence for this process. By analyzing the light emitted or absorbed by stars and supernova remnants, scientists identify precise spectral lines corresponding to specific elements, revealing their composition and abundance. Observations of ancient stars show lower concentrations of heavy elements, while younger stars, including our Sun, are rich in them, confirming that each generation of stars inherits the material synthesized by previous stellar deaths. Measurements of elemental abundances in meteorites, planetary crusts, and interstellar clouds further align with these models. demonstrating that the atoms composing Earth and life itself originated in stellar interiors. This leads to a profound, experimentally supported conclusion. The elements that constitute the human body, carbon in our cells, oxygen in our lungs, iron in our blood, calcium in our bones, were forged in stars that lived and died billions of years before Earth formed. We are not metaphorically but literally composed of stellar material. The universe sacrifices stars to generate complexity, transforming simple primordial matter into the chemical diversity necessary for planets, oceans, biology, and eventually consciousness. In scientific terms, stellar death is not an end but a mechanism of cosmic evolution, ensuring that each cycle of collapse and explosion enriches the universe further. What appears as destruction at one scale is creation at another, revealing that cosmic progress depends not on permanence, but on transformation, a truth written into the very atoms of our existence. This leads to a profound, experimentally supported conclusion. The elements that constitute the human body, carbon in our cells, oxygen in our lungs, iron in our blood, calcium in our bones, were forged in stars that lived and died billions of years before Earth formed. We are not metaphorically but literally composed of stellar material. The universe sacrifices stars to generate complexity, transforming simple primordial matter into the chemical diversity necessary for planets, oceans, biology, and eventually consciousness. In scientific terms, stellar death is not an end but a mechanism of cosmic evolution, ensuring that each cycle of collapse and explosion enriches the universe further. What appears as destruction at one scale is creation at another, revealing that cosmic progress depends not on permanence, but on transformation, a truth written into the very atoms of our existence. In Vedic philosophy, destruction is never interpreted as a final end or a negation of existence. Instead, it is understood as an essential phase of transformation within an ongoing cosmic cycle. This understanding is embodied in the principle of Shiva, who does not symbolize chaos or nihilism, but dissolution, laya, the process by which forms return to their subtle state so that new forms may arise. Shiva's role is often misunderstood as destructive in a negative sense, yet in Vedic cosmology, destruction is not opposed to creation. It is its prerequisite. The universe is seen as rhythmic, governed by cycles of manifestation, preservation, and dissolution, where each phase enables the next. Without collapse, matter remains locked in simple, stable configurations. Without dissolution, complexity cannot emerge. This insight mirrors modern astrophysics, where the collapse and explosive death of massive stars are necessary to generate the heavy elements required for planets, chemistry, and life. In this light, stellar destruction is not cosmic failure but cosmic renewal, an act of transformation that releases enriched material back into the universe. The Vedic vision recognizes that creation cannot progress through accumulation alone. It requires release, breakdown, and reconfiguration. Just as Shiva's cosmic dance dissolves old forms to clear the path for new expression, the universe sacrifices stars so that worlds may form, oceans may gather, and life may eventually arise. Destruction, therefore, is not an enemy of existence but its silent partner, ensuring that the cosmos does not stagnate but evolves toward greater complexity and possibility. Planet formation. From dust to worlds, planet formation is not a sudden or mysterious event. It is a gradual, well-observed physical process that unfolds naturally around young stars. When a star forms from the collapse of a molecular cloud, conservation of angular momentum causes the remaining gas and dust to flatten into a rotating protoplanetary disk surrounding the newborn star. These disks are not theoretical constructs. They are directly imaged by modern observatories such as ALMA, the Hubble Space Telescope, and the James Webb Space Telescope, which reveal rings, gaps, and spiral structures that mark planets in the process of forming. Within these disks, microscopic dust grains, composed of silicates, carbon compounds, and ices, begin the long journey toward becoming worlds. Initially, particles collide gently and adhere through electrostatic forces, similar to static electricity causing dust to cling together. As these aggregates grow larger, their gravitational influence increases, allowing them to attract additional material more efficiently. Millimeter-sized grains become pebbles. Pebbles merge into kilometer-scale planetesimals. Planetesimals collide and accrete into protoplanets. Over millions of years, gravity dominates the process, sculpting stable orbits and clearing paths within the disk, as emerging planets sweep up or scatter surrounding debris. This slow, step-by-step transformation is measurable through astronomical observations and computer simulations, which accurately reproduce the structures seen in real disks. The result is not randomness but inevitability. Given sufficient mass, time, and stability, dust will organize into planets. Planet formation, therefore, is not an exceptional event but a natural consequence of star formation itself, an expression of the universe's tendency to turn diffuse matter into structured worlds capable of hosting complex chemistry and potentially life. In Vedic understanding, the gradual formation of planets is expressed through Pṛthvī Tattva, the fundamental principle of solidity and structure. Pṛthvī is not merely Earth in the material sense, it represents the final stage of condensation, where subtle energies and forces stabilize into enduring form. Vedic cosmology describes existence as unfolding through a progression from the subtle to the gross: akasa, space; vayu, motion; agni, transformation; Āpas, cohesion; and finally Pṛthvī, solidity. This sequence mirrors the physical reality observed by modern science, where diffuse gas and microscopic dust slowly accumulate, bind, and compact under natural forces until stable bodies emerge. There are no sudden miracles in this vision of creation, only time, interaction, and accumulation governed by law. Matter does not leap into form, it thickens, layer by layer, through patience and persistence. Planets, therefore, are not anomalies or accidents scattered randomly across space, they are the inevitable outcome of cosmic processes operating consistently wherever conditions allow. In this view, solidity is not imposed but earned, through repeated interaction, gradual consolidation, and equilibrium. The Vedic insight recognizes that the universe prefers continuity over abruptness, evolution over interruption, and structure over chance. Planetary worlds arise because the cosmos allows matter the time it needs to settle into form, demonstrating that creation is not hurried, but deliberate in its unfolding. Water, the womb of life. When we reach the question of life's origin, speculation gives way to a striking convergence of evidence. Life does not begin in fire or air, but in water. This is not a philosophical assertion or a symbolic preference, it is a conclusion drawn from observation, experimentation, and planetary science. Every known form of life on Earth, from the simplest bacteria to complex organisms, depends fundamentally on liquid water as a solvent, a transport medium, and a regulator of temperature and chemical reactions. Accordingly, modern astrobiology defines the habitable zone around stars not by the presence of oxygen or continents, but by the possibility of stable liquid water on a planet's surface. Observations of young planetary systems and our own solar system confirm that water is not rare or accidental. Spectroscopic studies and space missions have verified that asteroids and comets contain abundant water, ice and hydrated minerals, and isotopic analysis of Earth's oceans suggests that a significant fraction of our planet's water was delivered during the early period of heavy bombardment. As these impacts subsided, oceans formed, creating vast, stable environments where chemistry could proceed over long timescales. Within these oceans, particularly near hydrothermal vents on the ocean floor, conditions existed that modern science recognizes as uniquely favorable for the emergence of life. These vents provide natural energy gradients, rich chemical environments, and mineral surfaces that act as catalysts. Laboratory simulations and theoretical models demonstrate that under such conditions, simple organic molecules can form spontaneously, assemble into more complex structures, and even exhibit primitive self-replicating behavior. Crucially, none of this requires a suspension of physical law. Life does not violate physics. It arises because physics and chemistry permit it. Water's unique molecular properties, its polarity, its ability to form hydrogen bonds, its capacity to dissolve a wide range of substances, make it an unparalleled medium for complex, dynamic chemistry. In this sense, water is not merely a backdrop for life but an active participant, enabling molecules to interact, organize, and evolve. Thus, the emergence of life appears not as a miraculous interruption of natural processes, but as their inevitable continuation under the right conditions. Wherever liquid water, energy, and time coexist, chemistry tends toward complexity, and in that complexity, life finds its womb. In Vedic thought, this life-giving role of water is expressed through the principle of Āpas, one of the fundamental elements described in the earliest hymns of the Rig Veda. Āpas is not treated as symbolic or metaphorical water, nor merely as a physical substance flowing in rivers and oceans. It represents the generative medium through which life and form become possible. The Vedic seers recognized that water possesses a unique capacity to nurture, connect, and sustain processes that no other element can support. In this understanding, water is the womb of creation, the environment in which matter transitions from inert complexity to organized vitality. Āpas allows substances to interact, dissolve, recombine, and transform, creating conditions where stability and change coexist. This insight aligns with modern scientific observation. Biological chemistry requires a solvent that can support dynamic molecular interaction without collapsing into disorder, and water fulfills this role with unmatched efficiency. The Vedas did not frame this as belief or doctrine, but as recognition of a recurring pattern in nature. Wherever life appears, water is present. Wherever water is absent, life fails to take hold. Thus, when Vedic cosmology places Āpas at the foundation of life, it is acknowledging an empirical truth observed across scales, that life consistently emerges in aqueous environments. Water is not merely a setting for life's drama, it is the enabling condition that allows matter to host awareness, making the emergence of life not an exception, but a continuation of natural order. When viewed without human-centered assumptions, life appears not as an anomaly interrupting cosmic history, but as its natural continuation. The same universe that forged stars also forged the atoms within them. The same stellar deaths that scattered elements made possible the chemistry of oceans. And the same physical laws that govern galaxies govern molecular interactions inside cells. From stars to atoms, from atoms to oceans, and from oceans to living cells, there is no break in causality, only increasing levels of organization. Modern science describes this progression as chemistry crossing complexity thresholds, where simple molecules, given sufficient time, energy flow, and environmental stability, begin to self-organize into systems capable of metabolism, replication, and evolution. These transitions do not require new laws of physics. They arise from the same principles of thermodynamics, chemical kinetics, and information theory that operate everywhere in the universe. Life, in this sense, is not something added to the cosmos from outside. It is what the cosmos does when matter and energy are arranged in certain ways. The emergence of cells represents a point at which chemistry becomes self-referential, capable of maintaining and copying its own structure. Seen from this broader perspective, biology is not separate from cosmology, but a late chapter in the same unfolding narrative. Life is the universe extending its evolutionary process into a new domain, where matter begins not only to react, but to persist, adapt, and eventually reflect upon the very processes that gave rise to it. In Vedic science, this continuity from matter to life is described through the principle of Chaitanya, consciousness not as a product of matter alone, but as a fundamental expression that manifests through form when conditions allow. Chaitanya does not imply mysticism detached from nature, it refers to awareness emerging as organization reaches sufficient depth and coherence. Where modern science speaks of complexity thresholds and information processing, Vedic thought speaks of consciousness expressing itself through structured matter. These are not opposing claims, but two languages describing the same unfolding reality. One approaches from measurement and mechanism, the other from experiential insight and pattern recognition. Both agree on the essential point: life and awareness do not stand outside the universe as foreign additions. We are not visitors observing a cosmic machine from the outside, we are products of the same processes we seek to understand. Born from stellar fire, shaped by oceans and chemistry, and held together by gravity, our bodies and minds carry the history of the cosmos within them. In this sense, humanity functions as cosmic memory, the universe remembering its own evolution through conscious experience. And perhaps, in allowing matter to reach a state where it can observe, question, and reflect, the universe has not reached an accident, but a natural culmination of its long, patient journey. The universe did not pause or conclude its journey once stars ignited and galaxies took shape. Evolution did not end with light filling the cosmos. It continued through chemistry, through oceans, through living systems. Life is not a side note in cosmic history. It is the next phase of the same unfolding process that began with energy, matter, and space itself. From nuclear fusion to molecular replication, each step follows naturally from the last, guided by the same underlying laws. The appearance of living beings marks a moment where the universe's evolution turns inward, becoming capable of self-reference and reflection. And in the next episode, we confront the most dangerous question of all, not because it lacks evidence, but because of what it implies. Is consciousness merely a cosmic accident, a byproduct of complex chemistry, or is it the destination toward which the universe has been moving all along?
Thank you for watching. I hope you like our video. Please don't forget to like and subscribe for amazing content. Join us for the search of truth.